Welcome to our last lesson in this unit on systems. So this one is on systems of inequalities. So we're only going to have one method for solving these, and that's going to be using a graph. And it's going to use a lot of the same things that we used in the previous unit when we were graphing inequalities, our dashed lines, our solid lines, that kind of thing. But now we're going to incorporate two of them at the same time, and we're going to look at where do they have some commonalities. What points are solutions to both inequalities? So let's start with a couple that are already written in slope-intercept form. So our first step is we just want to go ahead and graph them. My suggestion is it's helpful if you use colors. So each graph can be done in its own color because we're going to have solid and dashed lines. We're going to be shading in one side of the line or the other, and sometimes it's helpful to be able to tell one from the other. So my first one I'm going to do in red. So y is less than 2x plus 2. So it's got a y-intercept of 2 and a slope of 2. So it's going up 2 over 1. Or down 2 and back 1. It was less than, so I'm just going to use a dashed line because I don't want to include the actual line itself. Now I'm going to graph my second one, and I'm going to save the shading for a moment just because I'm doing two lines at once. So sometimes it's easier to draw the lines first and then come back and do the shading second. So y is greater than or equal to negative x minus 3. So I've got a y-intercept of negative 3. Negative x means negative 1, or negative 1 over 1 for slope. So I'm going down 1 over 1, or up 1, back 1. And it was greater than or equal to, so I'm going to go ahead and use a solid line. Okay. For this one, we're not as interested in where they meet. We're going to be more interested in their shading and where it overlaps. So I'm going to go back to my first one, and I'm going to plug in the point 0, 0. So I'm going to put in 0 for y and 0 for x. So 2 times 0 is going to be 0. So is it true that 0 is less than 0 plus 2? Well, yeah, 0 is less than 0 plus 2. So that means I want the point 0, 0. So I'm going to shade the side of my red line that included 0, 0. So same rules as it was from before. Now I'm just going to do it twice. So now I'm going to go back to my second equation. Y is equal to negative x minus 3. So I'm going to plug in 0, 0. Is 0 greater than or equal to 0 minus 3? Well, 0 minus 3 is negative 3. 0 is greater than that. So I want to include 0, 0. That's over here. So I want to include this right-hand side of my inequality. Okay. So here's the whole key to today's lesson. Where do those two inequalities overlap? Because that shading is the numbers, the values that are solutions to that inequality. We want to find numbers that are solutions of both of them, so we want to look at where they overlap. So this whole section over here, this whole green section, is solutions for both inequalities. So the next part says, give me 3 possible solutions. So 3 points in there. So maybe I'll pick this point here, and this point here, those yellow points. Well, that first one was at positive 3, negative 3. So 3, negative 3. My next one was over 5. 1, 2, 3, 4, 5, and up 1. So 5, comma 1. And then my second one was over 2 and up 3. So it's just choosing at least 3 points that fall in that overlapped shaded region. Last question says, is the point 1, negative 5 a solution to this system of inequalities? Oop, forgot the F there. So I'm going to find the point 1, negative 5. So over 1, down 1, 2, 3, 4, 5. That's this purple point right here. You'll notice it's in the shaded region for the red, but it's not in the shaded region for the blue. So the answer is no, it's not a solution to both inequalities. Or you could say it's not in the region that's shaded for both of them, not where it's overlapping. Okay? So let's see this again with another problem. So the whole idea is we're going to graph both inequalities, solid lines, dashed lines, shade the appropriate side, and then we're looking at where did the shaded regions overlap? What numbers, what points are values that work for both inequalities? So my first one I'm going to do in green. Y is greater than or equal to x plus 2. So a y-intercept of 2 and a slope of 1. It's greater than or equal to, so I'm going to do it as a solid line. Next one I'm going to do in blue. Y is greater than 2x plus 3. So I'm going to have a y-intercept of 3, a slope of 2. So up 2 over 1 or down 2 back 1. And I'm going to do a dashed line for this one. Make sure your dashed line stands out. We want to know where the line is, but we want to be able to tell that it's dashed and not solid. Now I'm going to go ahead and shade it. So I always like to use 0, 0 as long as my line doesn't go through it. So I put in 0 for y and 0 for x. Is 0 greater than or equal to 0 plus 2? So basically, is 0 greater than or equal to 2? No, it's not. So I don't want the side of the green line with 0 on it. I want the other side. Then for my blue one, I'm going to put in 0 for y and 0 for x. Is 0 greater than 2 plus, or 2 times 0, which is 0 plus 3? No, 0 is not greater than 3. So I don't want the side with 0, I want the other side. So I'm going to shade in this region. And then my solutions are basically everything in this section that I'm going to shade in a little darker. This is a good thing for you to do, is when you see that overlap, maybe darken in that section a little bit so it stands out. It's clear that I got shaded in by both inequalities. So let's pick some points over there. So maybe I'm going to pick this point here. That's the point -5, 0. Then maybe I'm going to pick a point up here. That's 3, -3, 4. And then maybe I pick one at -1, 6. Oops, sorry, those are hard to read. Now, I don't have to choose ones that are on my actual graph. I just have to choose anything that would be on that side. So I could do a -10, +10. That's going to be way up over here, but clearly that would be in that shaded region. So we're not limited to just the ones within the coordinate grid we can see, as long as we know it's going to fall within that range if the graph were bigger. Now we want to check the point 3, 7. So +3, +7. That's going to be just above my graph up here, this red point. Clearly that's in the green shaded region, but it's not in the blue shaded region. So this one is going to be a no. It's not in the shaded region. For both inequalities. Or you could say it like we did the previous one. It's not a solution to both inequalities. All right, hopefully you're getting the hang of it. In this example, we just need to do a little bit of rewriting with one of our equations to get it in slope-intercept form. So I've got my point slope form, so I'm going to do my distributive property. And I'm going to add 5 to both sides. I get y is less than -3x plus 2. So I'm going to graph that one first. I've got a y-intercept of 2 and a slope of -3. It's a less than, so I'm going to use a dashed line. For my other one, I've got a y-intercept of -4 and a slope of +3. And it's greater than or equal to, so I need a solid line. Now I'm going to do my shading here real quick. I'm going to plug in 0 for y and 0 for x. Is 0 greater than or equal to -4? Yeah, that's true. So I want this side that has 0, 0 on it. For my second one, I have 0 is less than 0 plus 2. Because we know -3 times 0 is going to give me 0. Is 0 less than 2? Yes, it is. So I want to shade the side of the line that has 0, 0 for my red one. So that's going to be this line right here. So basically this whole section over here is part of both of those inequalities. So let's choose some points here real quick. So I might have the point -4, -3. I could have the point -3, 2. So -4, -3, or -3, or sorry, -3, +2. And again, I'm just choosing points that fall within that range. I could even have -1, 0. Those are all possibilities for me. Now I want to check -1, +7. So -1, +7 is going to be right up here at the top of the screen, that purple point. Okay, so this one is going to be no, not a solution, because it's not in the shaded region of both points, or both inequalities, excuse me. All right, so my suggestion is at this point, pause. I want you to try examples 4 and 5 for yourself. When you're ready, go ahead, hit play. I've already started mine, and then I'll show you how I finish them out. Check your answers, see how you did. All right, so I've already got my 2 lines. My blue one, I'm going to plug in 0, 0. Is 0 greater than 0 plus 2? No, that's not true. So I want to shade the side that doesn't have the 0 on it. For my second one, I have y is less than -x minus 2. So 0 is less than 0 minus 2. No, 0 is not less than -2. So I don't want 0. So I'm going to shade in everything over on this side. So I've got this small little region here that I want to look at. Let's find 3 solutions real quick. So maybe I have the point -5, 1, or -6, 2. Okay. Maybe I could even go all the way out to -7 and 2. So I had -5, 1. I had -6, 2, or -7, 2. Just because I know my lines are going to continue going, even if my graph doesn't show it, I know those points are still out there. But those are points that are shaded in. Is the point 1, 5 a solution? Well, 1, 5 is this red point up here. This one would be a no. It's not a solution to both points. All right, last one. Again, try it for yourself if you haven't already, and then I'm going to go ahead and do mine. So I've graphed my first one. I'm going to plug in 0 for y and 0 for x. Is 0 greater than 3? No, definitely not. So I don't want the side with 0, so I want the other side of my graph. And then for my second one, I can go back to my original equation. 0 plus 0, is that greater than or equal to -9? Well, yeah, 0 is greater than -9, so I want the side that 0 is on. Okay. In this case, I get this region up here that I'm going to do in purple. That is my overlapped region. That's going to be part of both solution sets. So let's find 3 points there real quick. So maybe this point here, -3, 1. Here I've got -1, 6 up there, or maybe -5, -5. Those are all possibilities. So -3, 1, -1, 6, or -5, 5. So just identifying some points that fall in that overlapped region. And then I want to check the point -5, -6. Well, -5, -6 is going to be this one way down here at the bottom of my graph, that purple point. This one is definitely not a solution. Because it's not in the shaded region. For either inequality. So notice how both types of answers will work. I can describe whether they're solutions of the inequality. I can talk about whether they're in the shaded regions. That's all kind of talking about the same thing. But hopefully you got a good idea of how to tackle these, and then we're going to practice some tomorrow.